Okay, so I will go through with this OTA demo steps, step by step, starting from creating all the configuration related to AWS, down to downloading FreeRTOS, configuring the credentials, Wi-Fi settings, and creating the OTA job. Well, we have a full OTA update on the ESP32. So let's start with the Amazon configuration. First of all, we need to create the IAM user. IAM user is a user with some or specific credentials because we don't want to use the root user because this is a risky choice. So we need to just create an IAM root user with OTA and some access to the S3 bucket and some other feature related to OTA. So we go to our account on Amazon, search for IAM, and select users, add user. So we go step by step. So we add user, select a name for our user, whatever the user, we will use this name, my OTA user. This already created. Maybe I can delete it first. There's two options to create a password or to access through access key. This is an whatever choice you need, but you choose. But we can go with the pragmatic access. Next, we will attach some policy or some access to this user. So we'll choose attach existing policies directly, like we here are the steps, and we select these policies: Amazon FreeRTOS full access, Amazon FreeRTOS OTA update, and Amazon IoT full access. So we just search in the policies for these policies and select it. Second one, OTA update, select it, and Amazon IoT full access, and we also choose it. And we create and download the credentials CSV. So we just click next, next, and create user. So we have our user created. We download the credentials. So we'll need it in logging and creating our device on Amazon. Okay, so this is our uh, the username. There is no password here. It is the access key, and this is the secret access key. This is the secret that we'll use to access, and this is our user ID. So also this number we will need it later. Okay. We go back to our steps. So yeah, so here based on the steps, we download the CSV and we take note of the count ID, this ID in here, or in the IAM, this number. Okay, so secondly, we create policies and roles for OTA update and S3 bucket access. S3 bucket access, if you don't know, it's like a repository or storage for our open binary files that we will use through the OTA update. So first, we will need to create the Amazon S3 bucket to store this update. So we'll go S3, so we can search for S3. Go to SS3. I already have some. It's okay. So we create a bucket. Choose a bucket name. I already select some examples. Maybe this one. And normally I use this region US West 2, but that doesn't make a difference because we are on global. So maybe you can follow the same as the example here to avoid any mistakes. So, and I think we will go with all the defaults. Packet versioning will select enable. No, no encryption. So, and we create the uh, already exist. There's a problem with this bucket name. It's have to be unique. I don't over the all buckets. So I don't know why this. So we can select maybe um, my test OTA bucket. Okay, so we have our bucket created. Go back to steps. So yeah, we have choose the default permissions. We enable the versioning and we create a bucket. So we are finished with this step. So we go back to the IAM to create some roles and some and permissions and policies. So we go navigate to in IAM to roles. So we give roles. Maybe I can delete previously created roles. Create, and we select Amazon Web's AWS service from the trusted entity, and we also select here from use cases. We select IoT, and we select IoT. This will give us default permissions, some default permissions for the IoT access. So next, so we get these permissions. Um, So we just select the trusted Amazon service, we select IoT, select IoT, next, 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 and we create the name for the OTA. We select this name, OTA service role, next, next, OTA service role, create, and we have our service role create. After that, we need to add some permissions to this role. So we open the role again and select attach policies. So we go here, open this role. If you go back, we can go back, select roles, and select you the created our created role. And in permissions, we here we select attach policies, and we will search for Amazon FreeRTOS update, and we select it, and we can go finish it, or we can complete with attach a policy. We will complete with attach policy. So this policy already attached here. We continue with add some inlines permissions or online policies. So if we go back to the steps, yeah, to the steps, so I add IAM permissions to this route. So we need to our user or the user that we created to have access to this have the same permissions or have access to this role. So we open the same role we created. We already opened it. We choose add inline policy. So we here add inline policy, and we select JSON, and we copy this configuration replace this one with this one, and here we need to update the IAM user with our account ID and our role name. We can go back here, search for IAM again to open another one to keep this open, and we can go to our users, to our created user, and we can copy this account ID. We can take it here, go back to the roles, and we can remove all these. We can, yeah, choose another simple and easy one. So go here, select this one, and replace account ID with this. And we need to update role name with our role name, which is OTA service role. Remove this one. Review policy. I think this is a space, extra space here. This must have using spaces. Okay. So there was a leading space on the JSON. We just removed it. Yeah. So we create a policy. So we this policy need a name, so we can check for the default name, update account ID, and so on, so on. And we maybe this is example for the policy name, this IAM permission. So we name it OTA role IAM permission policy. So we now add IAM access to the OTA role. It's added. We also need to add S3 bucket access to our OTA service role. So this service, we need to access this S3 bucket, which will contain our binary files for the update, and we need to give it some access. So we do the same, open our OTA service role, add inline policy, select the JSON, and replace with this JSON. So we add inline JSON and replace, move the leading space, and we need here to replace this example bucket with our S3 bucket name. So we go back to S3, get our bucket name and replace it. And we can go with review policy, create policy. Yeah, we need a name for the policy. We can also use OTA role S3 bucket permission policy. You can choose whatever name you want, but yeah, I try to have a consistent example here. Okay. So we have this S3 bucket permission added to our role. After that, we need to create a user policy. So we need to give our user some permissions for the OT update, also SS3 packet, and so on. So we go to our user in the IAM console and choose add permissions. And as a role, we will add inline attach existing policy, and we create policy with the JSON. So we can. Okay, so now we need to create a policy to attach it with to give the user some access to over and permissions for the OT update. Sorry, this is not correct. We need to update it. This will go to policies, not the user itself. So we'll go to policies and create a policy. So here we go to policies and create a policy, and we choose JSON, and we replace it with this example or this, sorry, JSON. And for sure there is no leading space, and here we need this is gives access the policy to for SS3 access this is um, certificate management access, IoT access, FreeRTOS access, and over some resources, SSC access, and IAM access. So we need to update our example bucket with our bucket name, and the same for account ID and role name. So we can get our bucket name from the S3 bucket, update the name here, and from the users again we can get our uh, the role name with our role name, this one, and we are good to go. So next, and we give our policy a name. um, I named it here example or OTA user policy. Create policy. We have our policy, so we need to attach this policy to our user. So we go to our user as stated here in the steps. So we go to the user, add permission, attach existing policy directly, and we choose our created policy. So we add permissions, attach existing policy directly, and we search for our created policy and attach it next. So we have our user policy here. Okay, so the last thing in Amazon related to permission and so on, we need to give our user permissions to sign the software. Uh, um, Software should be signed before transferred to our device. So we need our user to have some permissions and some access to be able to use services for signing the OTA software. So we go to our we create another policy and attach it to the user. So we go to policies and add inline policy and create this one. So we go policies, create policy, and choose JSON. Nothing to change here, just allow the signer resources policy. Next, review and select a name. We can select OTE code sign policy and create policy. Our policy is created. We go to our user, attach existing policy, and select our sign policy. Next, next, and we have our sign policy attached. So we are now finished from the Amazon configuration. Uh, the second step will be to create a signing certificate. We have to create it on our device because this is related to our software, and import the certificate and private key to uh, um, to the signing profile later, but here we will create it first using OpenSSL. So okay, we can close all related IAM management here. We can keep only one opened. Okay, so we need to download and install OpenSSL and add it to environment variables. So if I open command prompt here, I should have OpenSSL installed. Yeah, I have it. So we need to implement a private key and a certificate. and sign this certificate with the private key. So there is an example here. We just create like a folder. Um, I have here which was created previously. We can use it. So I have here this folder. I create a folder called certificate, and we can go step by step together. So we just create a file. We can name it certificate configuration.txt and open it. Okay, and we add these values. We just need to change this with our email. We can use whatever email we need. Save it, and in this directory, so I have to go to this directory. So I opened command prompt here in Amazon FreeRTOS certificate and run the following commands. So first we need to create a private key. So we run this command, and we will find that a key was created. We need to create a certificate signed by our key, and we have our certificate. So we are okay with this step. We create the certificate and the key that will be used to sign our software and verify it when we download the software over ESP32. To to create things, certificates, and other um, uh, stuff related to Amazon IoT console, it's easy to use Amazon CLI. So we need to install Amazon CLI. We need to have like Python 3.4 or later installed with Python install package or pip, and we need to install CLI package using pip install Poto 3. I already installed it, but we can try again. So maybe you can check that we have Python using Python dash version. I have 3.8 and I will install CLI using this command, and it's already installed. So we can go and start configure the our AWS CLI access. So we will use our credentials downloaded here when creating the Amazon user, IAM user, to configure the Amazon CLI. So we how to configure? We just run AWS configure as stated here. He will ask for some information like Amazon access key ID. This is our access key ID. Our secret key. This is our secret key. And the region, we can keep it as West, US West 2 default, and the output format as JSON. We have our Amazon CLI configured. Okay, so we are good to go with final steps. We download FreeRTOS repository and install the required packages as like compiler and other packages. Create a thing in using CLI and update the headers file with the Wi-Fi, SSID, password, thing name, certificates, and so on. Update, select the demo OTA demo and build and flash. Create a job to make the OTA update. So first we need to download FreeRTOS repository and install the packages. I already have this Amazon repo already downloaded because it will take some time. Um, you just using GitHub, you can get this command that will clone and update all the submodule, and then we need to switch to the latest release. So here I'm on the latest master. So if I open git bash or any command with git and we check the branch, I am on master. So we can switch to the latest release using these commands. We first fetch all tags and we check out to 20 2012 00. This is the latest release tag, and create a branch with the same name. It's porting. Maybe check out dash F. Maybe I have some changes. Yeah, I have some changes here. Maybe I need to clear it first. I use also another tool. Yeah, I have here some changes. So I clean the repo. Nothing, no changes here. So I'm on the latest master here. Try again the command. Check out tags. It's importing for some reason. And tracked file will be yeah. So with dash F, it's forcing the switch. Um, but it will be some directory he couldn't delete. It will not affect us. It's okay. And we may also update the submodule using this command, get submodule update recursively. Make sure all the submodule are on the correct commit. Okay, so we are if we open like GUI to check what is the current branch. Yeah, we are here on the latest release. So it's okay now to continue. So we need to install the compiler and related packages. So we go to Amazon FreeRTOS folder, vendor Expressive, ESP run open the command prompt and install run the install.bat. This will download all the packages and all compiler and install it. I already done this step, but we can try it together here from vendors expressive IDF and run the command and run install.bat. It will try to download all the tools and so on because it's already done. It's skipping, and finally it will prompt that you need to run export.bat to populate all the environment variable. So we just run it. So it will add some paths and so on, and we are good to go to build our software. But before that, we need to continue here. So we finish this step. Okay, we need to configure and run and create our thing. So in the repo, we need to configure some the Wi-Fi SSID. So we go there is a Python script to easiate this step. So we go to Amazon FreeRTOS tools, Amazon quick start, open the JSON configuration JSON file and update the thing name. This is our device name. We can choose whatever name, the SSID, the password, and the security of our router. Normally it's WPA2 security, and we run the command python setup amazon.py python, and this will create all the related stuff in Amazon, and we'll check it that it's already created after we run this step, and we run this command to update the certificate created to communication in AWS IoT in our header files. So we can go with these steps. We go to SBI DF, we go to Amazon FreeRTOS tools, quick start, and we open the configured JSON. We'll find it as this. We will only change this thing name. We can use OTA device, for example. SSID, it's your SSID. Your password, it's your password. Security, I will choose WPA2. Okay, so I will update my SSID. Sorry. Sorry, I opened the file again. So I will add here my Wi-Fi SSID and Wi-Fi password. And we go back to this quick start and open a command prompt, and we run the Python script using Python setup Amazon and setup. This will create a thing in Amazon IoT Core, get the certificate and private key, and handle all the certificates and so on, writing this file to local file, this private key and certificate here, and complete update Amazon CLI credential .h. So if we open um, our certificate files, it should be here in demo, include credential keys. We will find that we have the keys already updated, and if we need to make sure, we can also run the command here to update the certificates, but we shouldn't, but it's already done here, so it's no need, but yeah, we can run it for sure to make sure everything is okay. Yeah, update operation completed. So yeah, we have the certificate and the key. This step is done, so we finished from creating a thing. So we need to make sure, or to double check, we can go to IoT console, IoT core, and open manage things, and we will find that our OTA device is created. Yeah, so this is what we already created. So everything went well. we need to complete the steps. So we need to build our OTA demo. So first we need to choose this specific OTA. There's a lot of demos that we need. The default one is MQTT Mutual Authentication Demo Enabled. We need to replace this with the config OTA update demo enabled. Back to steps. So we replace and update the OTA. Select the OTA demo update. We need to build. So in the root folder, we run this command to build our demo. So we go to FreeRTOS. I think we already opened it somewhere. Yeah, we can go to the root. So we are in the root folder, and because I already built it before, this folder is created. I can delete it. This build folder. For some reason it's attached to something. We can close all prompts. Try again, and we delete it. Yeah, open another command prompt and run this command. This command is a CMake command, choosing this vendor expressive and choosing the board as rover kit, compiler extensa, and using Ninja as toolchain generator. For some reason, yeah, because we opened a new uh, command prompt, so all the environment variable was gone. So we need to execute again the export.bat. So we go to vendors, expressive, ESP IDF, and run this export bat. Go back again to the root and run our CMake command again, and it should create the build folder and start building our demo. It will take some time to build. So this command, because we are not on the master, it's just configure the CMake. So we need to run another command to build. So it's idf dot by build. IDF, it's not working. We can go to build and run Ninja. This will do the same. Yeah, the environment on the latest release still using 3.3 IDF, so the commands and build commands is not updated. The latest one 4.2 is more easier, so we have to use the old commands and setup. So we are compiling the demo now, and we will flash it afterwards. Yeah, you need to have your board connected. So I will do this also right now. So the build is completed. We generated the Amazon demo binary in this folder, this one, and connecting the device ESP2 and updating the COM port. We give this COM port, so we need this number COM3 to be able to flash. So We can flash using um, cd. For some reason IDF.py should be used here because yeah, it's already, for some reason it wasn't recognized before. Yeah, so using idf.py, maybe I used another wrong spelling, whatever. idf.py, and we specify the COM port, which is COM3. First, we need to erase the ESP2 to make sure everything is clear. Erase underscore flash, so it will connect our port using COM3 and will erase the flash. After that, we need to flash and monitor. So flash and monitor what it's going on the ESP using this command monitor. We should expect that the ESP2 will connect using the Wi-Fi credentials and try to establish MQTT connection with AWS. If every step that we done was correct. So the flash is done, starting the demo, and we are already connected to Wi-Fi. It's trying to connect. Yes, it's connected to Amazon, and here it's creating a connection, establishing new MQTT connection. Connection was okay, and the task OTA task is ready. Connection is established, and the demo is ready, and it will forever wait for the job from the Amazon IoT core jobs for the OTA job that will be we will create uh, right now. So so far we are it's very good as what we have achieved so far, to have the demo running connected to Amazon and so on. Now the final step to have the OTA operation uh, using the IoT core. Um, Go back to our steps. Yeah, we finished this one. We flash and so on. Create the job. So we need to do some configuration here. We have to go back to Amazon core. We go to the manage jobs and create OTA job update and select our devices, which is OTA device, and next. Using MQTT as our protocol, we can change to HTTP, but we need to update also the HTTP on in the repo, in the header files. But we will go with MQTT. We will, for the signing, we will select or keep the IoT Amazon or the AWS to sign our software. So we need to create a profile to sign. This profile will contain our certificates and private key we created using OpenSSL. So we create a new profile. We, as the steps mentioned, we can name it OTA sign profile. Select the device. There is two rover kits here. I don't know what is the difference between them. There is no any difference, so I select the first one. And for the signing certificate, we choose our key, import our key and our certificate. So we have this certificate and we have a key, and this is a selected certificate chain. It's optional, so we can ignore it. Import. And for this path, this is for devices that using file system, but we don't have file system. We can just write whatever. I choose to write slash create the input profile. Yeah, this profile is already exists, so I create another profile with a different name. Not eSign profile, maybe profile 2. So our profile is profile 2, and select the device again, import the certificate, select the key, to slash here, import, and create. So we have our profile and it's selected. The next time we just need to choose it. You don't need to create it each time. For the selected S3 file. This is a point we have to take care here because we built our software with a version. Yeah, so this version found in this file, Amazon application version. It's in Amazon demos includes Amazon demos includes Amazon AWS application version. So the currently flashed software is with version 0.9.2 with a build version. If we flash or send the same version through OTA, it will be rejected. The rule here is that we have to the OTA binary should be larger than the current on the ESP on the device. It can't be the same or lower. So we need to like use a higher one, build it, and make sure not to flash. So we just go to build cmd and run Ninja to make sure we can delete this binary folder, and Ninja, it will just build because we changed only one file. um, what is here? Maybe I choose idf dot by build um, the export one. Sorry for this. Yeah, and because I opened a new I have to export again. cd vendors, no, not vendors here. cd vendors expressive idf esp idf and export. Okay, yeah, so this is our command. So we go back to the root, idf.py build. Yeah, so we have this one. This one is we can name it like version 2, or we can name it like 0.9.3 to make sure what is this. And we now can open or can upload our file. Select, we use our bucket. Our bucket is my OTA bucket that we created before, and we use upload file, and we use our binary file from the build folder. It's AWS demo binary, which yeah, we renamed it to version 0.9.3. Okay, it will be uploaded and it's selected. So this is the which should goes with the OTA. The same for the path file, just slash. And for the role, we will select the OTA role that we created before in IAM page, which is OTA service role. And next, we give a number or ID for the job. Maybe we can say it's version 09. I think it should have a score underscore underscore 3, and we keep, there is other options that you can use, but we'll go with the default, and we can go with create. I need to go side by side with the device. So device here is waiting for the job to be created, and we are about to create the job. So we create, we should find that the device will be notified and start. Yeah, so the device start to download. If we stop here for, so it's receiving files 4K, remaining blocks 265, and it's already received 10. If we go with it, it's continue receiving. So the remaining is decreasing and the received is increasing, and it will continue until it finishes. And at the end, we need to make sure that the OTA file was accepted. We can there is we can make sure of checking the OTA task or OTA demo version. It should be 093. We received almost the end of the update. 7 blocks, 6 blocks, 5 blocks, and it should restart twice. Oh, for some reason the verification failed. Hmm. For some reason, signature verification failed. I don't know why, but maybe we did something wrong with the certificates. Mhm. Okay, so the OTA failed because we I forgot a step of updating the signing certificate in the code. So here in the demos, um, OTA code signer certificate in the include. Yeah, because this was not included. So using the certificate we already created, we need to uh, first we need to edit it, but we can, yeah, we can uh, need to open it, open with Visual Studio. We need to copy this certificate and edit in the file, this file, OTA code signer certificate, that we need to edit it some. We need to add here quotation quotes here. We need to add backslash n quote backslash, and the same for all the lines except the last one, backslash n quote backslash backslash n quote backslash, and here just uh, quote, and this is okay. So we have to um, repeat the flashing and repeat the new version upload. So we can go with version 3 as the default for the flash. So we need just to build. So we can stop the device. We can, if we use this command, it will build first and flash, but we can make sure first that we build, and we flash. So the OTA task here with the version 093. Yeah, so this is the version 093, and then try to connect, and the connection is okay. Okay, so we need to update the application version again to, for example, 4 to be higher than the current on the software. We need to um, make sure to delete. It's okay, but we can just delete it to confirm, and we build again. And we rename this as version 0.9.4. And we upload it. We have to create another. The created one, it will fail if we check this. I think ETA4. This is ours. Yeah, it will fail because we have invalid certificate. We create another job. It will be easier here because we already create most of the stuff. Select the device, MQTT sign new software, and here we just for the sign we just select our profile, which was OTA sign profile 2, and we select the S3 bucket, which is my test OTA bucket, and we upload a new file, which is version 4. Okay, slash here, and select the service role. Next job we can set version 0, 9, it's 4, and we just create and check the device. Yeah, it's getting the update. So ATA4, maybe we can just refresh here to make sure it's here, because sometimes it doesn't populate. Yeah, so our OTA version here is in progress, and it's at the beginning it's in queued, and it's after that it's in progress state, and it will go to succeed or fail based on the status sent from the device. So we will wait until the device receives all the blocks, and we'll see whether it will, and it should succeed because we update the certificate, the signing certificate. So okay, we near the end again. So the certificate was valid, and it will restart to check the test the code. And it's already finished. We can go back to check the logs. Yeah, our demo is OTA demo version 0.94, and we already the test was okay. We can go back to check the all the signature and so on. This is the end of the completion. Yeah, file received complete and signature is valid. Stopping the timer, and it will restart to test mode, and after testing it should mark the, yeah, the version is updated, and starting self test and accepted. We can increase here. Sorry. Go back again. Make sure everything is okay. Yeah. Not this one, the one before. No, this one. Yeah, self-test again. Okay. Wait, complete. Success. Okay, device. Set the image as testing. Yeah, so here we set the image as valid one. So current image is valid. Sign signature is okay. Validate test is okay. And it's already used. And even if we start the software, yeah, it will be okay. So we should find that the job was succeeded. If we refresh here, the job was completed successfully. So this is the OTA from beginning from the Amazon configuration to FreeRTOS configuration and to the end. So thank you.